Ladies and gentlemen, today I will talk about project management challenges in major infrastructure projects in California using the example of San Francisco-Oakland Bay Bridge. The presentation consists of 4 parts, including project objectives, theoretical research on the project management challenges that will be further described in the San Francisco-Oakland Bay Bridge case, and a recommendation part. The objectives are to describe and analyze project management challenges in the major infrastructure project, evaluate the efficiency of the Bay Bridge project management, and provide recommendations from strategic, innovation management, and organizational behavior and HR perspectives. The research and analysis concentrates on the public funding projects carried out by an alliance of public and private companies. I will start by describing the project management challenges, including theoretical background and identification of the project management challenges and sub-challenges. The essence of project management is risk management. The project management challenges were evaluated using 3 main project risks: cost, time, and quality. There are 2 project management strategic challenges: complexity and uncertainty, that arise from definition of a project. Project is a temporary activity progressively elaborated through time within cost constraints that provides unique results and requires collaboration of many stakeholders. Sustainability is a third project management strategic challenge. Public awareness of environmental sustainability and public demand for social economic development have recently increased. According to the Sustainable Development concept, every project should satisfy 3 main criteria of sustainability: social, economic, and environmental. Interaction between the main project management challenges leads to further project management sub-challenges. The first 2 of them are balancing flexibility and planning and managing cost and duration. Projects with significant innovation are characterized by high level of uncertainty. Half of major construction innovation projects exceed initial budget by 40 to 200% and on average exceed duration by 10 years. One of the reasons is a corporate governance process. Innovation projects assume doing things in novel way that require flexibility. Corporate organizations behave bureaucratically, stifling flexibility and leads to sluggish change management. At the same time, high level of flexibility implies lack of planning. To cope with complexity, planning is required. Managing stakeholders and the decision-making process are another set of project management challenges. Stakeholders' involvement and alignment with project goals are often neglected. The public-funded infrastructure projects have a complex hierarchical organizational structure with many private and public stakeholders, characterized by different goals and level of involvement that make stakeholder management even more complicated. The decision-making process is slow as innovation projects require many changes that need approval from multiple managerial layers. Governance boards tend to be overly cautious and reluctant to give project managers greater decision-making authority. A lack of efficient information flows obstruct flexibility, speed, and accuracy of decision-making. Here you can see a summary of the project management challenges and sub-challenges in major infrastructure projects. Now I am going to concentrate on the project management challenges of the Bay Bridge project. I am going to describe the case and risk analysis findings, touch upon a value chain and organizational structure of the project. The old Bay Bridge was partially destroyed after the 1989 California earthquake. 6 alternative plans of rebuilding were proposed, and it took several years to analyze possible risks. The California State Governor Schwarzenegger approved one of the Bay Bridge construction projects only in 2005. The project that was approved had a single steel tower and self-anchored suspensions. The project chosen was the most expensive, however, it also the most publicly accepted and least harmful to the environment construction option. The project positioned itself as highly sustainable. Sustainability was reflected in the project's value chain. It generated jobs, created pedestrian and bicycle pathways, solved seismic and aesthetic concerns. organizational structure of the project was highly complex and implied participation of the public and private stakeholders. Evaluation of the project performance was conducted using the Iron Triangle framework. The project partially failed from time and cost perspective. The project's planned budget increased from 1.5 billion to 6.4 billion due to an entry of new stakeholder, Caltrans, and the most expensive and complex construction choice. Originally, construction phases were planned to finish by 2007-2012. However, the project was opened only in 2013 and some works are still unfinished. The project official media tried to diminish project management failures, emphasizing only a positive side, including the project's sustainability. To identify reasons for project management partial failure, the risk analysis was conducted using PESTEL, SWOT, the failure mode and effect frameworks, and stakeholder analysis. According to PESTEL, the most dangerous risks arose from technological, followed by economic and social macro-business environment. The weak and strong sides of a project were balanced. The strongest internal sides of the project include sustainability of the project and completeness of design. The most influencing weakness connected with technological and managerial risks. The most significant risks from the project unknowns were complexity of construction method and wide variety of stakeholders. The stakeholders analysis identified high variety of main stakeholders with different level of influence and involvement. According to the analysis above, the main challenges of the project were complexity and uncertainty associated with technical and managerial risks, while sustainability turned out to be an opportunity. Overall, the biggest project threats were complex construction method and managerial risk due to communication problem between stakeholders and high range of managerial agendas from engineering to design. The stakeholders had different views on the project objectives. For example, Dennis Mulligan, a Coltrane State Toll Bridge project manager, claimed that the purpose of the bridge is safety and not the beauty or economic development. However, public advocacy required the bridge to be acceptable not only seismically, but also stylistically and environmentally. The project duration and cost increased. However, the project also gained public support. Ted Hall, the program manager of Hedgemont MacDonald, claimed that the bridge plans and the soil structure required a creative approach to build a unique construction. The complex organizational structure made it hard to approve significant changes even though all companies followed the same standards and had common top management. A variety of key stakeholders implied complexity of stakeholders management. Technical and managerial risks would be possible to mitigate through establishment of a less bureaucratic organizational structure. Project managers should have more decision-making authority in tech-related questions. To be consistent with other participants' action and keep them aligned to the project goals, project managers should have organized efficient information flows to enable stakeholders' collaboration. Properly structured information flows would decrease uncertainty and enable change management process. Project managers should support PR activities, emphasizing importance to the greater public, making public advocacy aligned with project goals. Thank you for your attention.